Hello guys, my name is Diego Pacheco and this is another slidecast. Today we're gonna be talking about security and I have a slidecast to show you guys. And I want to cover some cultural aspects, some engineering aspects as well, some industry trends, and also talking about how we can protect our applications, right? So let's get started. So the slidecast I have is Security 101. So I put this picture here on the cover, right? Because I think this picture is great because it's actually wrong. This picture gives us the wrong sense of security, which is you look here how many key locks you have on this bar, right? And clearly all that key locks not necessarily make the bar more secure, right? Because security is something which is cross-cutting, and then you need to see the big picture, right? So it doesn't matter if you have your door, for instance, like being super ultra secure, if your window is wide open, right? So I though I put this picture here because everybody has the sense of locks in security, padlocks and stuff, but actually I would say that's not what security means, right? So I want to start deconstructing this cover picture. Okay, so we are used to security in the physical world, right? If we let software aside for a moment, we all have doors that have keys or access cards or passwords. In Brazil, it's pretty common to have electrical fences in apartments. In our cars we have alarms. Several houses also have alarms as well. It's really common and we don't feel awkward about it. It's something I would say almost natural, right? It's natural to have keys for your storage or for your door or for your car. In Brazil, it's completely natural to have electrical fences, and alarms are something which is, regular as well. And the reason why I'm saying, hey, this is normal and sane, and people are, I would say, fairly comfortable with physical world security, right? When we talk about software, then people get uncomfortable, right? And what happens is like security scares people. Engineers often are scared about security, and there are several reasons, right? I think one of the reasons is because if you look encryption, you have lots of math there, and people are afraid of math. Other times, as something like as culturally was not as as becoming as a big push right now. In 2018, you know, um, Werner Vogels from AWS, the CTO, said that everybody needs to become a security engineer. And I think that is interesting that happens in 2018, all right? Only 3 years ago, we are in 2021 right now. And that's interesting because I think that shows the fact that security is still sort of a myth or taboo. And that's really funny because, like I said, if we think about the real world, there's no taboo. Nobody said, no, I'm not locking my door, right? But when we're talking about software, it's still we got pushbacks. We have people that don't want to make systems more secure. And there's reasons about that. And I will comment about it later on when we talk about engineering and the engineering friction, right? But I'd say that we need to remove these myths and we need to make this regular and normal, and we need to talk about it, right? So we need to remove this fear of software security. We need to stop, fear about it, and we need to start understanding. And in the end, it's not something impossible. It's not rocket science. It's still possible for us to do it. And fortunately, there's lots of good materials out there and books, and that's something that we need to change. And the reason why we need to do that is because, first of all, I believe is about ethics, right? So when we are building software, we want to build the best software as we can. And when we're talking about building software, we care about so many dimensions, right? We think about architecture, about design, about testing. Today, it will be seen as something crazy to have software without tests, right? But not long time ago, that was completely normal, right? And but today is still sort of fine to not have security or not worried about, right? And I feel that's something culturally it needs to change. And I feel like this is as important as other disciplines like coding, architecture, design, databases, so many aspects of engineering that might be closer to the code or close to the user, like UX. So that's my second point, right? That you should care about security for customer experience, because no one likes to have their data stolen, no one likes to have losses, and this is damaging for the users. So your users are your consumers, and you want to provide the best consumer experience. And safety and integrity are important aspects of consumer experience, and often UXs don't talk about that, and that needs to be addressed. For a company, I would say that you also want to care about because of your brand integrity, right? As your company, you have like outages. If we talk about DevOps, that could be bad for your image. I also would say if you get hacked or you leak data, that's also bad for your image. So for your brand value, you really don't want to harass that image that maybe you take years or decades crafting that, right? And can go all away. So really, this is about integrity. So you need to keep your brand with integrity. And finally, for industries that they are regulated, you don't have a choice. You have compliance. You need to follow. Otherwise, you're gonna be in trouble. But you might realize here that I'm putting compliance as the last argument. This is not my first argument, because I believe we should do this no matter if you have compliance or not, for the other reasons. First of all, because of ethics, because we care, and as much as we care about other dimensions like architecture, testing, engineering, DevOps, so many, and because we care about our users and we care about the companies brands that we serve, right? So that are the reasons why I think this is important. We should have sort of a mindset shift here, but not necessarily because of compliance, right? So let's not use compliance as the reasoning. So talking about principles, I always like talk about principles way more than practices, because I think they allow us to guide us and navigate through complexity and have better decisions. And this slide here is the reason why I was kind of explaining my cover image, like so many the bar with so many padlocks there, which is the defense in depth. In security, you don't want to have super security in one layer and forget about the other layers. So what you want to do is to have security all the way down in all the layers. And if we think about software, right, and let's put security aside for a moment, and let's think about tests, for instance. In testing, we don't want to do just one kind of tests. Like, for instance, we don't want to just do end-to-end tests. We want to do integration tests. We want to do unit tests. We want to do chaos testing. We want to do property-based. We want to do fuzzing and so many other forms of testing. So it's not like we just have one form of testing. So we want to have testing diversity. And when we talk about architecture, we don't have just one form of architecture as well. We have data architecture, we have back-end architecture, we have front-end architecture, and security is the same. So you need to secure all the system, right? Not just one aspect. So we can think in so many layers, like data, application, the machine or the host, the network, the perimeter physically, and even policies and procedures, right? So what you need to do is to have security in all these layers, and that's how you roll. That's for me, that's the basic principle we need to follow. And we also need to acknowledge that security is similar to testing and similar to observability in some sense, which is security is a cross-cutting concern, so you cannot just do it in one place and that's it. All right. So this idea was originated by NSA. These ideas of securing layers in all IT systems. In the end, it's all about redundancy, because if one layer fails, you have another layer, right? And this end up reducing blast radius. And some forms of security, just to give you guys some examples, right? It could be AVs, antivirus, authentication, authorization, encryption, MFA, which means multi-factor authentication, sandboxes, which are getting popular, especially with containers nowadays, DMZs, VPNs, firewall, and so many other techniques, right? But you want, long story short, you want to do security in depth. The next principle I want to cover is called least privilege principle. And the idea is quite simple, yet we are not quite there. So the idea is like you give as minimum privilege or access or permissions as needed. You avoid to give everybody an admin account. So if you think about AWS, for instance, when you have resources, when you have roles, you avoid to have wildcards like asterisk, meaning yes, you can access all endpoints, all principles, and you can do it all. No, that's too much open. And the reason why we don't like that is because there's this principle of least privilege, and that's what you want to do. And the reason why you want to do that is because you want to avoid the attacker surface, because if the attacker get access to that layer, if his privilege and access is restricted to that layer, he cannot go any further. So this principle plays very well with the other principle of defense in depth. And also this principle is not only interesting if we think about an attacker which is invading our systems, but also if you think about malware. So malware as well could be spreading, and doing the principle of less privilege, you might allow reducing this blast radius and malware being more contained, which is something we definitely want to do. So these are the two key principles. Now that we talk about principles, let's talk about how we make our system secure and how we deal with some vulnerabilities. And I'm going to talk about the basics, right? So one important thing is encryption. There's basically two forms of encryption. There's symmetrical and asymmetrical encryption. Basically, symmetrical encryption, you have one or multiple keys, but you use the key to encrypt the data. And asymmetrical encryption is where you have a public and private key, which is used on SSH, for instance. Encryption, in a nutshell, is just encoding information, but it's not just encoding doing some cipher shift, right? It's more complex than that. And that's where we get into the math of it. So here on the right, I have a very simple scheme showing how encryption works. So you have plain text, which means clear data that's not encrypted. And this could be anything. Imagine like it could be your first name, your last name, your address, any sensible PII information like that, or SSN numbers. In Brazil, we have a CPF number, for instance, or RG. So any sensitive personal, identifiable, or financial information, let's say. So you want to encrypt this data, and once you encrypt, you're gonna get a ciphertext. A ciphertext is not a hash. Sometimes people confuse ciphertext with hashes, and they might look similar because they might look like handle strings. That doesn't make sense, and a good ciphertext has this property. But one fundamental difference, I would say two fundamental differences between ciphertext and hashes are that in ciphertext, you basically, even if you use the same key and you are encrypting the same data, so I encrypt Diego 3 times, I'm gonna get 3 different ciphertexts. And if I use hash, I actually, if I encrypt Diego the same time 3 times, I'm gonna get the exactly same hash. So hashes are predictable and they are consistent, and ciphertext, the idea is not to be predictable and consistent, but both in theory, hashes you cannot turn them back, so is a one-way algorithm, and ciphertext is a two-way algorithm where you can get them back, but in order to get them back you need to have a key. So it's really important to protect these keys. And for symmetrical encryption, you just basically have one key. For asymmetrical, you have public and private. So here, when we talk about the keys, it's important that you secure this key material, either in a solution like HashiCorp Vault or AWS's KMS, for instance. There are hardware security modules as well you can use, but you need to secure this key. By any means, you should not hard code this key. You should not put it on GitHub, for instance. Talking about symmetrical encryption, the default standard is AES, which stands for Advanced Encryption Standard. It is secure, is proven, is recommended by NSA, and is the most common algorithm used. So let me go back to the encryption explanation I was giving to you guys there. So when you have plain text and you want to encrypt, you not only have the key and the plain text, you also have an algorithm. So what this picture here is missing is the algorithm. And the algorithm that you use to encrypt could be AES. AES has modes, right? But we will not cover this today. One thing you want to do with encryption is to have key diversity. And this is very similar and very related to microservices. In microservices, you don't want to share databases. With encryption, it's exactly the same deal. You don't want to share keys. You ideally should have one key per application. And the reason why you want to do something like that is because if an attacker gets the key, it might get access to all your databases. So imagine like you did a very good job with microservices and you have different databases, but then if you're using the same key to encrypt everything, if the attacker get that key, get access to all your data. So it's really important to have key diversity. If you can have one key per service, in that sense, if the attacker get that key, you only compromise a subset of your data. Currently, all the cloud providers, AWS, Google, Azure, and also other vendors, they have something called envelope encryption, where it's a more complicated form of encryption. I will not go into details today. I intend to do a more deep dive encryption video later on. But envelope encryption, basically you have keys encrypting keys and encrypting keys. It's like a Russian doll. And that's what KMS does under the hood. I just want to point out there are some differences when we talk about encryption, because one thing is application level encryption and the other thing is storage level encryption. So when we are talking about storage level encryption, we have something which is transparent. So imagine that you are encrypting on S3, for instance, then using KMS and encrypting on S3. That's transparent, meaning the data, the application, after reading the data, gonna get the data in plain text. Right? So this is good at one sense because it's transparent. The application has all its capabilities, but at the same time, this could be less secure, right? Because if you get the data after the application read from S3, you have the data in plain text form. Application level encryption is a bit different. It means the application is doing the encryption. So let's say you don't use KMS on S3 anymore, or use it, but it doesn't matter for this case. And the application uses an SDK or service and encrypts the data. And then that data gonna be encrypted inside S3, for instance. And then if anyone gets the data on S3, they will not be able to decrypt it unless they have the key. So it's much more secure. But there is some side effects. This ends up sort of crippling some of the features. For S3 might sound fine, but for other data stores, this might create trouble for you, and you might not be able to use lots of features in your data store. So here we have more security, but you end up losing features. And with keys, for encryption, you need to have regular rotations, and that's also a form of our first principle, which is defense in depth. Because if attacker get a key, if you rotate the key every 3 months, for instance, which is a standard industry practice, right? Rotate the data every 90 days, then the attacker only can get it for 90 days. And if he get like an old key that is older than 90 days, he cannot do anything with that. So that's something important. And rotations, they also have another role, which is if you get breached, you also want to rotate your data. So rotations are things common to happen with encryption. Now let's talk about a second kind of encryption, which is the asymmetrical encryption. And one of the use cases for asymmetrical encryption is TLS or MTLS, right? TLS and MTLS, they're very similar. The idea is the degree of security you want to get. So TLS and MTLS, they allow you to have privacy and data integrity, basically securing connections and encrypting all the data that goes through the network. So let's say if you're doing a TCP application, for instance, or HTTP, and you are not encrypting that data is flowing over the network in a clear text form, meaning if anyone sniffs the network or does any man in the middle, your data gonna be leaked and the attacker gonna see everything that's going on. With TLS and MTLS, what you are doing is when you send data over the network, that data is being encrypted. And that's not only what's going on, there's more going on. So you basically have mechanisms to trust the server that you are exchanging information, that's the certificates. And you also have control on the degree of that trust. It can be one way or can be even both ways. So the difference between TLS and MTLS is that MTLS is both ways. So in TLS, the client needs to trust the server, and MTLS, the server also needs to trust the client, right? So you have even more security there. So in the way that TLS and MTLS work is they do asymmetrical encryption. Some of the use cases are email, chats, VoIP, and I think the most common one that people are used to is HTTPS. So MTLS is more secure because allow you to be protected against man in the middle. With TLS, it's still possible to do man in the middle, but with MTLS, it's not possible anymore. And because we have keys here, and because we have an encryption, but it's asymmetrical encryption, we need to do rotations as well. So you need to rotate your certificates. So here's just a comparison right now. The version of TLS is 1.3, and we should be using it plainly for two reasons, right? One, because it's more secure, and second, because it's faster. So here we can see both a full handshake between TLS 1.2 and TLS 1.3, and we can see that TLS 1.3 is much faster. We have one less round trip, right? When I talk about certificates, one standard that's often used is called X509. And one of the benefits of this standard is like there's many CAs, and CAs stands for Certificate Authority. Basically, in a nutshell, in the way this works, you have like a hierarchy of certificates and authority, and you have like root authorities or root CAs that are entities that you might trust, and they might verify that, let's say, Diego Blogspot, it is what he says he is, right? And I am Google are the one saying that Diego is Diego, and VeriSign saying that Google is Google, right? And then you have like this chain of trust. So the X09 standard has versions. It's a very common format. This can be stored or exchanged in a PKCS or PEN file format. Here are some visualization of the header, not the header, but like the whole protocol in sort of data, right? If we think about what kind of a data it can hold. And this representation, if I remember, is like for version 3. For version 2, we got some of these issuers part, and I think for version 3 got some extensions, and version 1 was more like if I remember, like subject and everything upward that. So this is what you're gonna see on X09 certificate. You're gonna see version number, serial number, signature, algorithm ID, issuer. You have a valid period, and that's important, right? So don't you need to kind of find a balance between, well, 100 years will be great, then I don't need to rotate anymore. But then if someone get this, they're gonna be accessing your data forever. At the same time, if I put 1 day, gonna be super secure, but also gonna be slower for the client that will need to be downloading the certificate. So you need to get some balance there, so to choose the right period. Another aspect you need to be concerned about your application servers and frameworks is configuration and error handling. Because by default, your server might be opening ports, and that ports might be used as an attack vector. And stack traces and error messages also could be problematic. Like here we can see SAP on ES server, and on the log we can see part of the code, and we can see some ID that has admin rights, right? So we did a exception with a null value, but end up showing a part of the code that shows a bigger vulnerability, and then the attacker can use that. And also we can see the version of the server downstairs on ladder 6, which allows the attacker to search for vulnerabilities for that version. So you really want to be careful with error messages for the end user. You also want to remove any default passwords like root, admin, Tomcat had stuff like that, on the past. And you also don't want to have software out of date because of vulnerabilities. And you also want to enforce security configs in order to protect yourself. Another important aspect, and that's more like for public-facing applications and public-facing APIs, but I would argue that any API and application should do this, but especially customer-facing apps and APIs. They need to sanitize all the data that came from the user and that came from other systems. Because one vulnerability that's often attempt is SQL injection, where the user has like a field username, password, and then he tries to inject part of a SQL expression, to go through and get access to the system and escalate if he can. So the fix for that, besides sanitization, is to use prepared statements. So pretty much all forms of all languages have forms of prepared statements. Java has it. That's also known as binding. So you don't want to do concatenation with strings to have your SQL. You want to do binding. You want to do prepared statements. You also need to be concerned with remote file inclusion. That's an interesting one. I see still several companies don't paying attention on this. This could be bad because it can reveal sensitive financial information, or could give the attacker an idea on what's going on, or could even allow the attacker to download data from your server, right? So let's say, imagine like I am in e-commerce and I'm buying something for me, and then in the URL I see something like OS, like service order 1 or 10 or 101. And if I do it again, I see 102. Well, that means if that's the case, that 102 sales happened before me, and that's the information that you are leaking. And one way to avoid that is to use something like an UID. Then no one can infer any sort of deduction on what's going on. and that's not only to protect your data integrity, but your financial informations. And you need to be careful with images as well, because let's say I am on a website, let's say like Airbnb, and then I have, you know, some private photos, let's say, that you only can see after you hand the house, right? Something like that. I'm making stuff up. And then if I see that a photo ID has 1, 2, 3, I might try 4 and 5. And that might be able for us to directly access a file there, right? And this is really dangerous because it may allow us to download data that, you know, people think they are protected, but they're not. So really be careful with that. Avoid paths that are deductible, and even sequences, I would argue, right? That you prefer to always sanitize your inputs. You want to strip tags, and you want to use UUID rather than sequential numbers. Now, a very common vulnerability as well is called XSS, or cross-site scripting, which is a form of injection. Mainly can be sort of a DOM, HTML, or JavaScript injection, where you have a URL and you also pass a script, and there's like two flavors of it. You know, it could be like a storage where, you know, you send that script, and who gonna see that data is not you, but an admin user. Imagine there's an admin user that reads the data to do some approval, and then if that code runs, you're gonna be running on an admin account, and then you might be able to create a lot of danger. Or there's another one called reflected that, you know, go back to the user, and it still can be problematic. So for the client to protect against this, you need to use the latest browser versions. You can also, there's some anti-phishing software you can have it, or plugins. For the server, you basically need to do sanitization, right? You need to sanitize all inputs. That's super important. Another vulnerability, or another form of attack we need to worry about, is insecure serialization and deserialization. XML is a full plate with trouble. There's one called XXE, external XML entity. In order to save space in a payload, you want to reduce latency because XML is kind of a big. There's this technique called external entity, where you sort of can put a link of the entity, and then the server can download that instead of basically, you know, passing that data all the time. And you might see this in SAML, which is a very common form of SSO, single sign-on, and also for SOAP web services. So if you're using SOAP, God bless you, and do not use SOAP below 1.2. And also you need to disable, if you're not using SOAP, just using XML, be careful when people are uploading XML to you, or when you are reading XML from other systems. In Brazil, we have something called NFE, Nota Fiscal Eletrônica, which is like a standard online invoice for services, and is XML. So it could be a vector attack vector. So you want to disable XML entity, and you also want to do DTD. You want DTD processing an XML entity disable, and you want to do validation. You don't want to allow tags you don't know. So you want to validate against a schema as XSD. And people think that this is, you know, just with XML. Actually, with JSON could be problem as well, but more in sense of a deserialization. Imagine something like in your path, you say, create this data for me. Here's the user John, and his role is user. Well, can I change that XML and put admin there? What happens? Does John become admin? So you need to be careful what kind of a data do you expose, even with JSON or other formats, because again, this could be an attack vector, and the attacker might be able to pass the different data that when you deserialize, it may be a problem. There are lots of interesting resources, sources of unknown vulnerabilities, Like OWASP top 10 is a very good one. They talk about the most common forms of attacks. Is a good way to educate yourself and also protect your systems. There is these two other lists, CVEs and CWEs. CVE is a common vulnerability exploit, and CWE is common weakness enumeration. And these sites, they have like catalogs of attacks and how they are manifested and how you can protect yourself. It's also important to have code analysis tools running your side. If you think about engineering, there are tools when we are talking about testing, for instance, like PMD, check style, cobertura, which can check for testing coverage and also trying to find bugs like PMD and find bugs. And similar tools providing statistical code analysis can do that for security. And you might be able to get stuff like hard code credentials and things like that. And then this will be useful for you to detect it. And as a good practice, you also want to keep your software up to date. And here I want to say something, because when people read this, keep the software up to date, they might thinking about, oh, I'm gonna update my browser. Yeah, that's great that you update your browser, but your libraries also need to be up to date. And that's where often the problem happens, right? But we will talk more when I talk about engineering in a moment. You also want to have logging and audit trail, and you want to avoid applications and systems having local logging or logs that is hard to extract informations. And you also want to avoid unmonitored log. You really want to have audit trail in high value transactions, because even your internal users could be doing an attack. That could be an attack vector, and looking the log, you could be able to get something and take action. So you really want to do monitoring on suspicious activities. And this is also where this log processing could be meeting with big data. Like you could be reading logs and sending to Kafka, and then have like machine learning algorithms to analyze what's going on and see if there's a suspicious activity going on or not. Like for instance, I am a credit card company and I see that Diego always expend $100 every month in Amazon buying books, but now I see that he's spending $2,000 in this Aruba based website that he never went there, and I see that his last purchase was in Brazil. So how Diego got in Aruba that fast, right? Is he traveling? So you might raise a flag there. So that's why you want to have this audit trailing on high value transactions. We also have threat analysis, which for me is something that is becoming popular nowadays. So threat analysis are basically you modeling your systems and then you understanding attack vectors and planning how you can secure them. Of course, all models are wrong, but some are useful. And these allow us to see the threats and even allow us to prioritize better. And in my point of view, they might democratize security, meaning hopefully this will become more and more like a team activity, as teams are doing testing as well. Engineers do testing, they also be doing threat analysis. And there's this cool tool called Threat Agile. I have a video about it. You can take a look on my YouTube or in my blog. It's a very interesting tool. And finally, now is the time to talk about engineering and the friction with engineering. So in my understanding, what's going on is not new at all. If we think about it like 10, 20 years ago, tests was not something common or usual. So culturally, I still believe the universities do not teach engineers how to do tests. Some teach nowadays, but there are ones who doesn't. And basically, that's a cultural change, right? And I remember in projects that always the last thing to do was tests. And if there was a hard deadline and you need to sacrifice something, you're gonna sacrifice tests. And that was the case. And I feel like that's sort of a change. At least in awareness, lots of companies they have tests now. Maybe it's not the best quality or the best coverage or the best diversity, but for sure, no one will argue that it doesn't want to do tests or is a waste of time. And I see similar thing happening with the DevOps movement in sense of automation, in sense of having engineering in operations like version control, automation, monitoring, and not doing clicks, automating things with code like infrastructure as code. And I believe like security is going through the same drill, right? So today is you're often gonna see teams pushing back to doing security activities, even questioning the value of security. But I believe this will change, and I believe like just like tests and DevOps, it will be something that will become normal and part of everything activity. I just want to say that depending how you do security, it might cripple some engineering capabilities. Like when I was talking about encryption to protect your privacy of your data. If you are doing like envelope or application encryption, meaning you encrypt the data in your application, then you send to the database. If you think about a database like Redis, if you're using strings, you might be fine, but another data type, you might lose several functions on the data. If you think about Elasticsearch, it might be not able to search at all because how are you going to search on the ciphertext? Elasticsearch actually has some interesting capabilities to provide hashing, but it's not the same. And if you think about database, relational database, you might be having problems with uniqueness. You might have problems with joins. You might have problems with full partial search as well, like likes. So you definitely want to weight this very well. But I also feel like besides there's some friction, there's also motion from security. And I think that's something interesting because security is sort of refactoring enabler, right? Because as you need to have software up to date, you need to update your libraries, and we need to update libraries, right? And that's great updating libraries because that give you chance to have better software, with patches, with fixes, new features. Engineers always love to use the latest and the greatest versions of software. So security can be a friend on that sense. If you think about InfoSec departments, and instead of getting friction, you might get motion, and security might help you to keep up improving your software, right? So that's definitely a very cool thing. And the only last thing I would say is that security is not everybody Joe, is everybody job. My text got cropped there by the image. Sorry about that. And Voges from Amazon said that, and I believe in 10 years or so, I believe we're going to be in a totally different state about security. I believe that's something that teams need to do more and more. And I hope this slidecast help you to see that and also to learn more about security and to understand more about it. So that's what I got for today. I hope you guys like it. See you next time. Take care. Cheers.